Okay, so starting with rotation. Rotation is a turn. So right up here, just make a note for yourself. Rotation is a turn on the coordinate plane. Rotations spin about a center of rotation, and we'll look at that in this lesson. And then a figure can be rotated clockwise or counterclockwise. So clockwise being this way, but this would actually be a negative rotation. Negative. And again, this builds, so if it doesn't quite make sense yet, it will in a second. And then a counterclockwise rotation, so if the shape is going in this direction, it is a positive rotation. Okay, then right here, all points on the image must be equidistant from the center of rotation. Go slower. Or am I going too fast? Or am I good? Or do you want me to slow down? Oh, okay. So all points on the image must be equidistant from the center of rotation as the points on the pre-image, and we'll look at what that means. Okay, so over here, we have a center of rotation right here, and then this shape. If we were to rotate this positive 90 degrees, it would rotate this way. So positive 90-degree rotation would go this way. And all of these words here mean that from the center of rotation, when you rotate it, your image is going to be the same distance away from the center of rotation. So this length right here would be the same length this way. And then you would draw your shape. And then also notice that this angle right here is 90 degrees. Okay, now what if you had a negative 90 degree rotation? A negative 90 degree rotation would go this way. And same idea, it has to be the same distance from the center of rotation. And then draw your shape. And again, this would be 90 degrees this way. Okay, next. Okay, so over here, it's just giving you a visual of what we're doing, and then we'll get into like what the points look like in a second. We're actually not going to fill out this chart at this point. We're just going to focus on this over here. So what you have right here is your original, your pre-image, and then they're rotating this shape around the coordinate plane. So from here to here is a 90-degree rotation. And if you wanted to check this, just take a corresponding point on both of these. Let's call this an L. If you take like the boot of the L, point D right here, it corresponds to this part of the L over here. And you should be able, if you connect it to the center of rotation, which is the origin, it should make a 90-degree angle. Okay, so what if you have a 180-degree rotation? So that would be this image right here is a 180-degree rotation. It's like 2 turns on the coordinate plane. And again, if you were to draw a line from the corresponding point on this shape and this shape, it should be a straight line being 180 degrees. And then this one down here is a 270-degree rotation. So it'd be like 3 turns on the graph, 270 degrees. And again, if you connect it to that corresponding point right there and add these angles up, you should get 270 degrees. That says 270 right there. And then 360-degree rotation, it would land on itself, if you needed me to point that out to you. Okay, next page. Okay, so now we're going to look at what happens to the points, or a rule for the points as you make your rotations. So this says 90 degrees counterclockwise, so that would be a positive 90-degree rotation. Counterclockwise is positive 90. So when we rotate this shape, we're going to rotate it like one turn this way. And the shape that would come out would look like this. Some of you will be able to visualize this better than others. Everybody has like different skills in terms of spatial reasoning, just based on your brain. Boys apparently have better spatial reasoning than girls, so it might be easier for you to visualize this than me, because I know that I kind of have trouble with that. Okay, so we did a 90-degree rotation and got this, and we can kind of check it. If this point corresponds with this, then we should be able to draw an angle through the center of rotation and get 90 degrees. Now, a positive 90-degree rotation, or one turn to the left, is the same thing as 270-degree rotation clockwise. So positive 90 degrees is the same as negative 270 degrees. Focus. You can do it. There. Okay. Some of you might be able to visualize that. Some of you might not. So there's actually a rule for the coordinates. And the rule for positive 90 or negative 270 is negative yx. And we'll use this in some examples coming up. Okay. Now we're going to look at 180 degrees counterclockwise. So 180 degrees would be positive 180, or it could be negative 180. Same spot. And when we rotate this 180 degrees, it's going to be like two turns, so it'll end up over here. And drawing this out, be like right here. There's a new one. Okay, so there's our transformation, positive 180 degree turn, or if you wanted to do a negative 180, it would land in the same spot. And then the rule for 180 is the easiest rule, just negative x, negative y. And then last but not least, we have the 270 degrees counterclockwise, so that would be positive 270 degrees or negative 90 degrees, puts it in the same spot. So this would be like three turns. It would go all the way over here. There is our shape. So that is 270 degrees or negative 90 degrees. And the rule for this one is y negative x. Okay, and moving down here, rotate counterclockwise when rotating positive degrees, and rotate clockwise when rotating negative degrees. So when it's going this way, it's positive. When it's going this way, it's negative. Okay, now we're going to practice actually doing rotations with the points and everything else. Okay, so first example, it says graph the figure and its image under the given rotation. It says rotate the figure 90 degrees counterclockwise. So that would be a positive 90 degrees. Once I identify that, the next thing I'm going to do is find the rule. So looking at that top chart, the rule for positive 90 degrees was negative yx, and I'm going to write that down so I can continue to reference that. So it's negative y x. Next step, I'm going to take my original points here and just write them down. So for J, K, and L, what are the coordinates? So for J, it's 1, 2, 3, -4, -5. For K, and L. Like that, JKL. Okay, so I wrote down the original points. Now I'm going to use the rule to do the transformation or the rotation. So I'll have J prime, K prime, and L prime. And it says -yx. So this -y, it means like opposite. So here we have -5, so it's just going to be +5 here. And then x just stays the same, and it goes in this position now. And for K, now we repeat. Now we just plot the new points. And remember, it's 90 degrees, so yes, the shape should just be one turn over here. And that's it. That's your 90-degree rotation. Okay. Ready to do it again? Okay, next one is 180-degree rotation, which in my opinion is the easiest one of them all in terms of like the rule. So for a rotate a figure 180, it doesn't say positive or negative, it just assumes it's positive. So it's a positive 180-degree rotation, meaning that you're going to do 2 turns. It's going to end up over here somewhere. And then the rule for 180, just look up at your chart. It is -x, -y. So first step is just to list out the points, the original points. So L, M, N, whoa. Weird. That's so random. Okay. So point L is at 1, 3. I'm just pulling them off the graph. And then for the rule, it's -x, -y, so I'm just going to change these to the opposite sign. So I got L prime, M prime, N prime, and O prime. Zero doesn't turn negative, it just stays 0. Then once I've transformed my points, I can plot them. random. Okay. Next. Okay, down here. So now it says triangle ABC in a 270-degree rotation. If I look up at the top, the rule for 270 is y negative x. So I'm going to write that down here. So for positive 270, it is y negative x. And then I'm going to plot the originals. Originals in a 270-degree rotation would be like 3 turns. It's going to end up in quadrant 1. And then I need to transform my points. So A prime, B prime, and C prime. Okay, so y negative x. So I need to take this y and now put it in this position. And then x needs to turn to the opposite sign. And then plot the new points. Last one, or last, I guess, 2. It says if 0.52 is rotated counterclockwise 90 degrees, so that would be a positive 90-degree rotation, about the origin, its image will be point what? Well, for positive 90 degrees, the rule is negative yx. So for 5, 2, that would be negative 2, 5. And then, so that would be this answer. And then how does a spinner appear after 270 degrees counterclockwise rotation about point P? So here's the original here. If I was to do a 90-degree rotation, it would be pointing this way. If I was to do 180, it would point down. And then one more turn, and it would be pointed in this direction. So this is my answer. It would be B. There's one more thing, though, that I want to go over because it's on the homework. Okay, last thing, and it's pretty easy. It's called magnitude of rotation. So just make a quick note, magnitude of rotation. Okay, so let's say you have a perfect pentagon, a regular pentagon, and it asks for the magnitude of rotation for this shape. What it's asking for is how far you'd have to rotate it so it would land on itself. So in a perfect pentagon situation, you would do it like one turn like this, and it would land on itself. And how many degrees, you're trying to figure out how many degrees that would be. Well, if a full rotation is 360, one turn like this for a pentagon would be 360 divided by the number of sides. And then you would get 72 degrees. So if you had a, let's say a square, and you were asked what the magnitude of rotation is, how far you'd have to rotate it to get it to rotate onto itself, it would be 360 divided by 4, which would be 90 degrees. So magnitude of rotation, just take 360 divided by how many sides, and that will tell you where it lands on itself. Okay, take your time with the homework. If you have any questions with the homework, please let me know. Of course, you'll need to keep this out, especially the rules to do the homework. When you finish the homework on Schoology, then work on Khan Academy. And let me know if you complete homework in all 10 Khan Academy, and then you can get your phone if you want.